All right, so like I said, 6.3 is vectors, and again, very different from what we were doing with law of sines and law of cosines. We're going to talk about what a vector is today. We're going to find something called component form and magnitude, and then we're going to dive a little bit deeper in them as the week progresses. So a vector, by definition, is basically a line segment that has direction. So it's a line segment. Notice that this starts and ends at a point. So it's a segment, which means it has length, like you can actually measure it. But there is an arrow on it that points in the direction of the terminal point. So it points away from the initial point or the starting place, and it points towards the terminal point. That direction is kind of like slope. So the way we say the direction on any kind of vector is we give the change in x and the change in y. Instead of writing it as a slope as like a fraction, we write it side by side. It's called component form, which we're going to see in a second. But that has direction. So this one is moving to the right and up. This would have like positive change for each one, okay? There's two different ways to name a vector. One is using the initial point and the terminal point like this. And when you do that, you'll always see an arrow over half of that. The point that it's over is the point that's the terminal point. So because this is PQ, P is the initial and Q is the terminal. The other way you'll see it is just like that, a small or lowercase letter that's either bolded or italicized. Okay, so you could name it with either one. Two letters with a little arrow over one side of it, and then the other way is by a single lowercase, either bolded or italicized letter. Like this would be vector V or vector PQ. So the first thing we're going to find of our vectors is called component form. Component form is the change in x followed by the change in y inside these brackets. So these are not parentheses, these are brackets. This would be change in x, comma, change in y. If you compare it to like rise over run, this would be the run, comma, the rise. It's always got a comma separating the two, so it's never one single number. It's got the comma separating the two, and it's in those brackets. Those brackets mean that this is not a coordinate point. This is actually a change in x and a change in y. So I do the second or the terminal x minus the initial x, and then the terminal y minus the initial y. And that's important, otherwise the signs get switched. Okay? So it's not like slope where you can pick them in either order. Component form has to be picked in the correct order. The second thing we're going to find is magnitude, which is the length of the vector. If you're given the initial point and the terminal point, then you can find the magnitude using the distance formula. The square root of x2 minus x1 squared plus y2 minus y1 squared. If you're given the component form already, then you want to go straight to the magnitude by doing the square root of a squared plus b squared. This should have double bars on it. That should have double lines on it. That represents the magnitude. So if I saw this as a question, that means find the magnitude of u. So the double bars is not absolute value. Okay, the double bars means magnitude. Equivalent vectors are two vectors that have both the same magnitude and the same direction. So their magnitude and their component form have to be the same. So we're skipping example 1, I'll come back to it, but I think it makes more sense to do it this order. Find the component form and the magnitude of vector V. So A gives you initial point is -1, 5, and terminal point is 15, 12. So I would find the component form by doing the x coordinate of my terminal minus the x coordinate of my initial, so 15 minus a -1, comma, the y coordinate of my terminal minus the y coordinate of my initial, 12 minus 5. Simplify that. 15 plus 1 is 16. 12 minus 5 is 7. So the component form of this vector is 16, 7. With me so far? Today is so boring. I'm so sorry. But there's no way to make this more fun. I tried. Like this morning, I was like, what could I do differently? Not happening. But I've just been talking to sleepy faces all day. All right, then magnitude. Okay, so magnitude, you have the two choices. Because you have the initial and the terminal, you could do the whole distance formula. Okay, but we're already halfway on the distance formula by using the component form. So I would just get the square root of 16 squared plus 7 squared, because that's A and B. And the square root of 16 is 256. And the square root of 7 is 49. Oh, I guess those are big numbers. Those you could use the calculator and feel good about yourself. Yeah. And then you get the square root of 305. I would try to see if I could simplify that. So that's 5 and 61 doesn't go any further. So this is the magnitude of vector V. All right, you do B.
Miss Chris Weiser?
Yep.
Like when you wrote when it said the vector.
Okay, so we should have gotten this. The component form is 8, 6. The magnitude is 10. So if you actually thought about if we graph these two, right? If I actually had drawn a coordinate grid, it won't be perfect, but if we could approximate it. -3, 1, 2, 3, 4, 5. -5, there's my initial point. 1, 2, 3, 4, 5, up 1. This would be what my vector looks like, right? I've got my initial point, I've got my terminal point, the arrow points towards the terminal point. If I actually measured this on like a 1 centimeter by 1 centimeter grid, I could actually take a ruler and measure my actual length, and that should be the same thing as 10 centimeters, okay? If I look at the slope of this line, normally we do rise over run, but if I'm looking at component form, it's the change in x and the change in y. So if I actually count here, 1, 2, 3, 4, 5, 6, 7, 8, there's my change in x. Up, 1, 2, 3, 4, 5, 6, there's my change in y. So that matches my component form. What shape did I just make? A triangle, a right triangle, right? So if the change in x is 8 and the change in y is 6, and this is a right triangle.
7.
Oh, so close. What's the component? What's the triple? What's the triple of 6, 8? I failed you. 6, 8, 10 is the triple. Oh my God, if you can't get through pre-calc honors and learn triples, we are screwed. 6, 8, 10 is your triple, okay? So the magnitude would complete a right triangle if they're both. So if it was like a 3 and a 4, do we know the triple on that one?
5.
Thank you, 5. 3, 4 would have been 5. Okay, so does that make sense?
If we didn't know the triple, hypothetically, we could just use the right side of the problem.
Sure.
Got it.
Yeah. No, it's just to show that everything overlaps. But yes. And then if you don't know those triples, oh my God, I hate COVID. You have to learn triples. Okay? It's like one of the most important things you'll learn this year. All right. Now go to example 1. Show that U is equivalent to V. So we said that both things have to be true. The component form has to be the same and the magnitude has to be the same. Okay? So these should be dots. This is really hard to draw in PowerPoint, so I'm lazy and you just got an arrow at the end. Those should be dots.
Miss Chris Weiser, could you go back to the slide?
So if I wanted to find the component form of U, my initial point's actually 0, 0. This one should be easy to count and or just look at my terminal point. The change in x is 2. The change in y is 3. So this is 2, 3, which also happens to match my coordinate point. If it starts at 0, 0, it will always end at the coordinate point.
Wait, why do they label it U if that's one of our variables? You got would they name it?
But that is U, so U1 is 0, 0, and U2 is 2, 3. So it'd be, yeah. The vectors will usually be U's, V's, W's. There'll be letters like those.
So when we show the brackets, it always has to be next to the letter of the actual vector.
Well, if there's more than one, you want to put it next to it. If it's the only one, it doesn't matter. Yeah. And then the component form, this time it's not 0, 0 to that point, so I actually have to find it, right? The change in x, so this is my terminal, -2 minus a -4, and then -1 minus a -4. That becomes plus, and I get 2, and this becomes plus, and I get 3. So yes, already I'm showing my component forms are the same. What else do we say has to be the same? The magnitude. So the magnitude of u, because I already found my component form, is the square root of 2 squared plus 3 squared. 4 plus 9, I hear you. Square root of 13. That's the magnitude. Yeah.
Why do we have to show this if it's all going to end up like, if it's all going to end up being the same?
So if it says show that they're equal, the work is your show. If it said are they equal, then it's a yes or no. You don't have to do all the way through. Yeah. And the fact that both the component forms are the same means that both the magnitudes are going to be the same. We just need to show it. So this would be square root of 2 squared plus 3 squared. 4 plus 9 is square root 13. So those two are the same. So it's just like a verify. We know that they're going to be, but you have to show the work to prove it. So if you think about it, it will always happen that if the component form is equal, then the magnitude is going to be equal. So if I'm looking at two of them and the component forms are the same and I square and add them, it's always going to be the same. However, it is not always true the other way around. Okay? If the magnitude is equal, the component form doesn't have to be. Oh, what the heck is that? I don't even know how I did that. I kind of don't want it to go away. Because think about it, if I had like 2 and 3 and I did -2 and 3, the component forms are definitely different, right? But what happens when I square those and add them together? They're the same, okay? So if the component form is congruent, then the magnitude is going to be congruent. But if the magnitude is congruent, it is not necessarily true that the component form will also be congruent. And we get something called a scalar multiple. And this big, long paragraph just means that a scalar multiple is a number. It has to be a real number, so it can't be imaginary. It could be positive, it could be negative, it could be a fraction, it could be decimal, okay? It's just a number. So scalar is just a number. And we can put the scalar on the front of a vector and distribute it in just like you do with parentheses, okay? So it changes the length of your vector. If I give you that this is V, right? So if this is V, if I give you like a little string and I said that's vector V, find me 2V, it would be twice the length. It has to have the same slope, it has to go in the same direction, it's just twice the length. So if you actually measured it, and if this is easier on like Notability, if I actually took that little segment and I put it over here, and then I duplicated it, it's going to give me 2V. So it's got to be twice the length. If it's 1/2 V, it's half the length of the original one, okay? And then there's two things happening here. One is there's a negative. Notice that my arrow changed direction. So it was originally pointing up and to the right, like it had positive slope. Now it's pointing down and to the left. That's the negative part. The 3/2 part, that's really saying 1.5 times. So we took that V, and then we took another half the V and added it onto it. Yep. The negative changed the direction of the arrow. So if I'm drawing this on which you're going to eventually have to do, when you're drawing this on like on a coordinate grid, let me just draw like a. Let's say this is vector V, right? And the arrow is pointing that way. Vector -V would point this way, opposite direction. So the arrow would come away from it. Does that make sense? Because instead of going right and up, we're going left and down. Yep. All right, so these are some of the things that we can do with vectors. If I have the vector u, the vector v, and a scalar, which remember is just a real number, then I can add two vectors together. I can subtract two vectors. I can multiply a scalar in on a vector, so this would just be a number that gets distributed in. And if there's a negative on the inside, I could take it out. So you could distribute a negative in, you could take a negative and put it on the outside, okay? That negative is changing both the directions of my x and the y. Hi, Miss Farrier. Okay, so the other thing you're going to learn to do today, which is kind of like what I just showed you, is sketching the vector. And you have two ways to do this. If you're given the component form, like if it actually says the change in x and the change in y is this, then you start at 0, 0. And then use the vector as the terminal point. So this is if it just gives you the vector. If it said u is 2, 3, like we just talked about, then I would start at 0, 0. Change in x is 2, change in y is 3, and there's my vector. If it doesn't give you the actual vector and it says this is my initial point, this is my terminal point, then you literally plot your 2 points and connect them, point the arrow towards the terminal point. And then the only other kind is like what I just showed you, where it could give you an actual vector that you don't know the coordinate points, and you have to double its length, or you have to triple its length, or cut it in half, or point it a different direction. I'll show you that in just a minute. But that's the other kind. So there's 3 different ways to graph. If you're given the initial and the terminal, just plot them and point your arrow towards the terminal. If you're given the component form, then you start at 0, 0, and you use the coordinate point of the component form to be the terminal point. Or if I give you something like this is v, find 2v, then you would just double the length of v. So sometimes they give it to you without having any kind of coordinate points. All right, so this one says find A, u plus v, B, u minus v, and C, 2u minus 3v. Then sketch each resultant vector. So we're going to do them one at a time, and then we'll go back and draw them. So the first one is A, u plus v. So I add the x's in both. 2 plus 1. Then I add the y's in both. 1 plus 3. And my resultant vector is 3, 4. Easy stuff, right? B is u minus v. So obviously the order is important here. You want to make sure you do the u points first. So this would be 2, this 2 minus this 1. And this 1 minus this 3. And I get 1, negative 2. C is 2u minus 3v. So I'm going to take the 2, multiply it in on the 2, 1, and then take the negative 3 and multiply it in on the 1, 3. God bless you.
Thank you.
You're welcome. So distribute here. I get 4, 2. Now I can distribute the negative with the 3 and make it a plus in between. Or I could have done 4, 2. Minus distributed a positive 3 and then subtract. You could do that either way. Doesn't matter. But now I want to do first and first. So 4 plus a negative 3. And then second and second, 2 plus a negative 9. And I get 1, negative 7. Questions so far?
Is that the hardest it gets?
No. So now I'm going to go back and graph them. Everybody's okay if I move on? Anybody still coming down? Okay. I'm going to come back and graph these, and I'm going to show you both ways. The graphing as is, I think, is easy. if I say 3, 4, I'm going to start at 0, 0. Whoa. I'm going to start at 0, 0. The first number is my change in x. I'm going to go 1, 2, 3, up, 1, 2, 3, 4. I'm going to connect them. I'm going to draw my little arrow. You with me so far?
Yeah.
Yeah. So here's where it gets tricky. What if I hadn't give you exact values? So if you're doing something other than paying attention right now, like wake yourself up, focus on what I'm about to say, okay? Because what I'm about to show you is actually easy once you get the hang of it, but it's so obscure and you haven't seen it before that you're going to freak out the first couple of times. So let's say I don't have exact values there. Let's say I was given the initial 2 as a drawing, okay? So that would have looked like this would have been U, and this would have been V, okay? So pretend I gave you absolutely no values there. I just gave you drawn vectors. And then I said to find U plus V. So the way we do this is we go to the end points on each of them, draw a parallel segment the same length as the other side. So if I come to here and I want to draw something that goes up, I want it to be parallel to the blue one, and I want it to be about the same length as the blue one. So we went up 3 and over 1, so I know how far to go, but I may not know that on an open grid that doesn't have any tick marks, okay? So you just want to kind of eyeball. I want to draw it up about the same length as the blue and parallel to the blue. God bless you. Then I want to do the same thing off the end of the blue. I want it to be parallel to the orange and about the same length as the orange. It should, if I've done it correctly, intersect the other one. And the point where they meet is the terminal side, or the terminal point of their sum. So if I compare this to what we drew, they should be the same. Yep.
So you're basically just building a parallelogram?
Yeah. You're extending out the sides and building a little parallelogram, and where your two sides meet is the terminal point of your vector, okay? Of the sum of your vectors. So then if I went to the second one and it said 1, -2, easy way to do it is literally go, change of x is 1, change of y is -2, start at 0, 0, draw your arrow. And part of the homework, that's all you have to do. Like, you're going to actually have the value, and you're going to draw it, and you're going to pick it because it's multiple choice. But then you're going to get some that you have to draw based on the actual diagram and not the points. So if I did that again, I'm going to start with the same 2. So right 2, up 1. This is still U. 1, 1, 2, 3. This is still V. Oops. There. Now it's minus. So this one was my U. I should have done it different colors, but I didn't. This is my U. This is my V. Instead of adding them, the negative is the V. So I want to take the V, which is that blue one, and I want to go the opposite direction. I want it to be the same length or about the same length. This would now be -V. And then I want to make a parallelogram with these two sides. So I'm going to go parallel to that black line about the same length. And I'm going to go parallel to the pink line about the same length. And there's the terminal point. And that would be U minus V. Wait for it.